Hi, so welcome to Google Developer Africa. It's a broadcast. So just a quick intro. We're all GDEs here. The GDE program, we are appointed in different regions, acting as resources and people to guide local students and companies, just help with Google and just directly chat our needs back to Google HQ and see if they can help us in Africa. So let me just introduce the premise of the show. We're going for monthly, downloadable MP3, which we hope you can get, a video to watch later. Let's see how that goes. And we're looking for people to invite to the live hangouts. So later in the show, we're going to post out links. Please go to the form, fill it in. We'd love to have you. And we're really trying to base this off a theme-based. So every episode, we're going to try to focus on one thing, which in this episode you might see the title. I'm going to hand off to Hiren now, who's going to explain and introduce the panel.
Thanks. Hi guys, so an introduction on who's on the panel today. I am Hiren. I'm a cloud-based GDE in Cape Town. Johan, who you've met, is a cloud-based GDE in Cape Town as well, and the founder of a few startups here in Cape Town. We have Alex, Android GDE, and the author of the Cape Town My City Android app. And Dale, Cloud GDE and CTO of Nominini here in Cape Town. So you've seen that the theme for this episode is staying connected in Africa. And it's all about giving your users a good experience, taking into consideration the internet connectivity challenges of Africa. So as we all know, mobile is king in Africa, but in large areas, the mobile networks and the mobile connectivity can be very patchy, high latency, low throughput, and even non-existent. Now, most mobile apps today make use of a cloud-based backend, which is generally very great, but the problem comes into play when these apps don't take into consideration that they don't always have access to this cloud backend. What happens as a result is that they aren't able to provide the basic functionality to the users, and this gives the users a bad experience on the app. So all apps in Africa need to be able to provide the base functionality even when they can't access their cloud backend. And that's the discussion, that's the topic of discussion today. We're going to go into some depth on the problems as well as some solutions around this. So the schedule going forward, we will have Alex and Dale present on the subject for 10 minutes. We will then have a Q&A session for 5 minutes. We will have a closing and wrap-up for 5 minutes thereafter. If you have any questions, please post the questions to the YouTube video section, and we will take those questions in the Q&A. Just before I hand over, we have our latest Cloud GDE, Kenneth, joining us from Nairobi as well on the panel.
Hi, yeah.
So I'll hand over to Alex and Dale to kick it off.
Hello everyone, I'm Dale. Mobile networks in Africa can often be unreliable, and they drop calls and connections at the worst time. Data is also expensive, with some networks charging as much as $1 per megabyte for data. So firstly, I'm going to talk on the basics of how mobile networks work and why things sometimes go wrong. And then I'm going to talk about some things to keep in mind while you design your app. And then hand over to Alex, who's going to talk about some of the potential solutions for overcoming these problems. We're going to switch over to some slides quickly. Let's get them open here. So while your phone is switched on, it is always connected to at least one mobile base station. And if it isn't, it tries hard to get connected. And say you want to visit a web page on your phone sends that request to the nearest mobile base station, which routes your data to a switching center, and then from there it's routed onto the internet. As you travel around, your phone roams from base station to base station. Up to 7 towers are connected to your phone at any time. This allows your phone to hand over between towers seamlessly, so data and voice calls don't get dropped. Your phone sends data to any tower it's connected to, And the tower routes that data to a switching center and then onto the internet. And replies are sent back from the server that you're connecting to all the towers that your phone is connected to, and then back onto your phone. This is sort of like a monkey swinging from branch to branch. The monkey won't let go from one branch before it's holding on to the next one. But sometimes the branch that you want to go to has too many other monkeys on it, and there's nowhere for you to go. So say you're traveling and you're connected to your first base station, and there's loads of devices on the second base station. You don't know that, but you continue traveling towards the second one, that base station that's now overloaded. Your phone is still connected to the first tower, and your data connection or your voice call is fine, but you can't get to the second base station because too many other connections are open on that one. Eventually, you travel too far from the first base station, the signal is weak, the connection breaks, but you're still not connected to the closer, busy base station. And at that point, the call fails because you're not connected to anything. And if you're trying to use data, well, you can't get a data connection either. So let's look at what's happening under the hood. GSM networks, which is primarily what we use in Africa, use what's called TDMA, or time division multiple access, to allow many devices to connect to the same base station. Each base station has 124 channels, roughly at about 900 megahertz or 1800 megahertz. And each channel has 8 time slots. Each phone will transmit during a time slot for a few milliseconds, and then the next phone will transmit for the next few milliseconds, and so on. This happens so quickly that you don't notice it. It's very similar in the way that operating systems can run many programs, even with only 1 or 2 CPUs. On a base station, some time slots will be used for voice, and the other free time slots can be used for data. As more people use the base stations, the networks prioritize voice over data because they earn more money on voice calls, so they reduce the number of data time slots available. Eventually, if a base station is completely overloaded, all the time slots are used for voice and nothing is left for data, and you can't get any data through to the servers. So that's a little bit of the background of how mobile networks work and why sometimes your calls are dropped and you can't get a data connection even when it looks like you've got good signal. So given that data connections can be flaky, what can we do about it? Well, the first solution is to transmit as little as possible. Data costs are expensive, some people paying as much as $1 per megabyte. And if you're using HTTP, you can reduce the data by using a compact data format like JSON instead of XML. And you can use gzip for something like a 30% saving. What's up?
We're not presenting.
Oh.
Sorry, can we just switch back to that?
Still connected? Oh, there we go. Hey, I'm back. Cool. So as I was saying, if you're using something like HTTP, you can use JSON as a compact data format over XML, and then you can gzip it. And we found that gzipping data can have as much as a 30% saving. But something that I only realized recently is compression is only on the server side and for downloads. If you want to compress uploads, you probably have to roll something like your own. You can use gzip or another protocol like deflate. But I found it's worth it. And some data that I've been doing, we've had as much as 50% saving, especially when you batch those uploads. Some apps might not need to use data compression because you may be uploading images or movie clips, and formats like JPEG and MPEG, which are used for images and movies, are already compressed, and compressing them again with gzip is not going to help much. Just remember to resize your photos on the app, on the client side, before you upload them. You can also batch requests and responses. If you're doing many small requests, there's a lot of overhead in HTTP headers, and a cookie, which is used for authentication, can be as much as 1 to 2 kilobytes versus maybe 100 or 200 bytes that you're trying to send up, and that's a 10 times overhead instead of on your body. HTTP 2, which is based on Google's Spidey protocol, overcomes these issues. It's already supported on Android using the OK HTTP stack. All modern browsers support it already. And that only sends those headers once, and there's many other optimizations that you can do what it's got built in for mobile usage. You can also only send when you need to. If a server needs to send a message to a client, use push messaging. Don't poll the server the whole time if you need to get a connection. WebSockets is an interactive connection between the server and the client, and the server can send data to the client without it having to poll. SSL, which is encryption, is important and prevents things like third parties from sniffing the data and man-in-the-middle attacks, especially over public Wi-Fi like internet cafes, coffee shops, airports. But the problem is it adds latency to your application. It takes 12 packets to negotiate a SSL connection, and that's 3 round trips over the mobile network, compared to just 3 packets or 1 round trip if for an unencrypted TCP connection. But if you're using something like HTTP2, keep the connection open for as long as possible and it's reused. Reducing data also has the benefit of reducing battery usage. Continuously transmitting data, especially in poor signal areas, uses a lot of power because when the phone is struggling to get a signal, it boosts the transmit power to get your data through. And on that note, if you're using GPS, think about how often you really need to update the position. GPS uses a lot more battery than even GSM comms. Fused Location Provider on Android estimates a position based on the cell network and surrounding Wi-Fi base stations, and so your app doesn't need to use GPS as often. Data and battery-hungry apps get deleted by users, or worse, they get a 1-star rating. I'm now going to hand over to Alex, who's going to talk about building Android apps that handle these difficult network conditions.
Thanks, Dale. My name's Alex, and I'm an Android developer. And from what Dale's presented, it's pretty clear that we have some challenges to overcome with these networking problems. The good news is that the Android framework actually handles a lot of these things for us, at least in the recent versions, KitKat and Lollipop. But using the open OK HTTP library, you can get the same results using older versions of Android. And this generally takes care of things like request retries, simple caching, selecting the right protocol, such as HTTP2, and other low-level things like that. What we're going to do is discuss some techniques you can use while building your apps to help you create the best possible user experience, even when the network isn't being your best friend. First thing is storing everything on the client. Persist everything in an appropriate data store, such as SQLite. This means you'll always have data available to show immediately in your UI if you have a slow or no connection. Even if the data is a bit old, it's usually better to show that than nothing. By combining a sync adapter, content provider, and cursor loaders, which are all available in the Android framework, you can update your data in the background and always be sure that the latest data is showing in the UI immediately. Speaking of the UI, never block the UI when you're doing networking requests. As a user, there's nothing worse than being stopped in your tracks while you wait for some networking task to complete. Whether it's fetching new data or posting a new message, there are very few times it makes sense to block the UI and prevent the user from actually using your app. This is especially true on slow and unreliable connections. If you need to indicate that there's an ongoing process, use a small inline progress indicator inside your views. This shows the user that something is happening, but doesn't stop them from using the rest of your app. But even better is if you save the changed data on the device and update the UI immediately, and you can assume that the request will finish successfully. However, if it doesn't, you must alert the user that it's changed and roll back that change that you saved. This can be a little bit tricky, but I think it's well worth it in my opinion. There's one special case where you do need to block the UI, and that's when your app first loads or after a user logs in, when there is no data to show and you have to fetch it from the server. It's important to fetch that data as quickly as possible. However, most apps have a summary dashboard type screen where we show a bit of everything, a summary of the entire app. And if you have a nicely designed RESTful API, that means you'll have to fetch information from a number of different endpoints. What I usually do is I combine those into a single API endpoint that allows me to fetch all of the information for the first screen in one single request, which is far more efficient than doing multiple requests on the network. And this results in a shorter load time for your apps. One other thing to keep in mind is always push data to the devices whenever possible instead of polling. As Dale mentioned, this is a preferred technique in terms of data transfer because updates get to your users faster, but it also has less of an impact on battery and data costs. You can use Google Cloud Messaging for this on Android. That covers some basic techniques we can use for handling unreliable and expensive networks, but how can we get the backend up and running quickly? I've used App Engine a few times recently, and it's a great option for a low-maintenance backend. You can use Java to get going quickly, and there's a free daily quota that's fine for most apps. However, it doesn't offer specific support for any of the things we've mentioned today out of the box. That's where things like Firebase come into play. Firebase is described as a complete backend solution. There's no coding required or even possible on the backend. It basically provides an API for your data and handles other things such as authentication and common networking tasks. One of the benefits is it's cross-platform, so it works on web, iOS, and Android. But the real gem of this software is the client-side SDKs. They support offline mode and data synchronizations. That means that you can persist data on the device while there's no network connection, and then in the background it'll synchronize that with the server. This is one of the trickiest problems to deal with, so it's fantastic having that done well for you. There's also a free pricing option to get started. I haven't used it extensively, but I do think it's great for prototyping, especially for apps that require real-time syncing, such as multiplayer games or web applications. So to wrap up, remember to always store your data on the device so you can display it immediately. Never block the UI when doing network requests. Load all of your data you need up front in a single request, and push data to the device instead of polling for it to save battery and data costs. With all the links to the things that we've mentioned in this talk, but feel free to let us know so that we can share that with you.
Cool, thanks guys. So we're now going to take some questions. Just a reminder, if you're watching this live on YouTube, please post your questions on the YouTube comments. We're watching those as well. So for the first question, what apps would be a good example of how to handle connection failure well, and how do they do it?
One app I think does this quite well, at least on the web, is the Gmail inbox app. When you're typing an email, you don't get any indication that it's saved or not saved. You assume it's saved. But if you lose a connection, there's a subtle reminder that this draft is not saved. But it lets you continue with what you're doing, and when the network comes back up, everything's synced again.
I've got one to add to that. One of my favorite apps is 8Tracks. It's a media, well, basically like an online radio station. Except what they do in the background is they stream an MP3 to your phone. So it's not trying to do live streaming of content like over Shoutcast. It just sends an MP3. And as soon as the first MP3 has been downloaded in the playlist, it downloads the next one. So there's always something there. So when you're in spotty connections like in a lift or an underground parking, it still works pretty well.
Nice.
Yeah.
Okay. So syncing framework and it stops working. How would I know about this? What should I do as a developer? Yeah.
Well, when I was playing around with Firebase, there are things in the SDK to allow you to react to a failed connection or failed sync. And it's really up to the application and depends on the context of your application, how you bubble that up to the user, whether you do it at all. Sometimes you can just throw away data. Sometimes you don't want to throw away people's love letters. So it depends on the app, but the frameworks all allow a way of knowing what went wrong and how and when it went wrong.
Cool. So for the next one, can sync frameworks work with hybrid apps, given the rise of hybrid apps these days?
Well, if a hybrid app is just a web app running in a web view, theoretically with something like Firebase, you could use the web SDK and get similar results to native. But I doubt the reality is quite that simple. Every time I've been involved in a hybrid app, it has never been simple.
You're not a great fan of hybrid apps, are you?
How can you tell?
What about using like HTML5 offline storage?
Yeah, that's actually a really good example. I read something just the other night about how, I think it was Google, years ago, they started downloading massive CSS and JavaScript files, chopping them up into strings, and then storing those strings in local storage.
Right.
So if it didn't have the CSS and JavaScript required for the page, it would just go and request the pieces it needs.
Okay.
So there are imaginative ways you can use HTML technologies.
Right.
Cool. So what is the difference between GPR? Any comments around that?
Sure. Most of my knowledge is on 2G networks, so the GPRS and Edge, and that's from, I guess, from the early thousands, and uses TDMA and is pretty reliable and available almost everywhere. A lot of the networks started rolling out 3G and then HSDPA, and that uses a whole completely different protocol for doing for transmitting and receiving data. It's, as far as I know, it's CDMA, so it's just a different stack, entirely different frequencies, and a lot of new networks are now using LTE, and the newest ones in Africa, you find that they skipped right over 3G entirely, and they're installing LTE now. So they might have GPRS and might have Edge, certainly don't have 3G, and then now installing LTE. And the guys that don't install LTE now might skip over to whatever's next.
Well, that's great news, actually, because I've read and experienced that 2G is the painful experience, but 3G was a great advancement on that, but there were also problems, especially initializing the radio on mobile devices. It can be up to a 2.5-second delay from when you make the request to when it actually leaves your device. And LTE and HSDPA made massive improvements on this, where those times are down to under 100 milliseconds. So the future is looking fast.
Nice. So, do we have any other questions in the panel? It doesn't look like it.
You could always, after the event, we are live in the community, so just post your questions.
Yes, so if you haven't joined the community, please do. So if you have questions or anything we've spoken about, please post it there, and we'll be happy to answer it at a later point. I'll hand it back over to Johan.
So first, thank you, Dale and Alex. Awesome talk. This is the section where we would like to have you, the community, come and show us what you're doing, any problems you're experiencing, and just spotlight what the rest of Africa is doing. So we decided to keep it blank and rather do a call out. After the show, we're going to put out a post with a link, and just follow the link and fill in the form, and we'll get in contact. Especially with the theme-based shows, we're looking for something that fits, and just something that's generally cool and shows how innovative we are in Africa. So next up, it's Alex and Hiren attended ScaleConf. I don't know if you guys know it. It's a conference down in Cape Town. They're going to tell you more.
Yes, thanks, Johan. Hiren and I recently attended ScaleConf in Cape Town. It's probably the conference with the best venue in the world. It's right here in Kirstenbosch Botanical Gardens. And we gave a talk on scaling Android apps with Google Cloud Messaging and App Engine. The talk itself is fascinating, and the video will be available soon. But I wanted to talk more about ScaleConf and what makes it great. And I think it's because it's really well organized, has an interesting content in the tech talks, and also the format of it, a single track format with breaks between every talk. It worked really well. Everyone was always attentive and enjoying the talks. So we'd love to see more conferences like this in Africa. So please let us know about any conferences or events that you've really enjoyed so we can share a bit about them.
On the topic of events, we have an events category in the G+ community. We encourage everyone to go and look for events over there, events run by your local GDG. If you are a GDG organizer, please reshare your events under the events section of the community there for everyone else to see as well. On that note, I'd like to make mention of two upcoming important events. The first one is the Google I/O. So this is Google's annual major developer conference. And folks, so they live stream this as well. and folks around the world, including GDGs, will get together for extended viewing parties and sort of watch the live stream together. So do look out for an extended party near you, or even start one if you don't have one, and share it with us in the community and let us know about it as well. The other one is the UX Masterclass. So this is a Google-run workshop type event. Happened for the first time last year, and it's all around user experience and user interfaces. If this interests you, this is happening in the beginning of May in Nairobi, Cape Town, and Lagos. So look out for that as well. They are posted to the event section of the community as well. So back to Johan on the future of the show.
So let me just take us out. First off, thank you for coming to watch the first episode. We're still trying to find this show, but this was our structure show, so please, afterwards, give us feedback. We're going to be posting a link, so just tell us what you liked, what you didn't like, and rate it from boring to awesome. That's the and also, very important, the guest speaker. We'd love to feature you. So thank you for attending, and hope to see you next time.